All right, guys, so we are going to finish up lesson 2, these last few problems. You can see the one we're working on, a couple more slides. So let's take a look at where we left off. Okay, so in this problem we had to find both x and z. We labeled our angle of interest as this 20 degree angle. We could have used the 70 degree angle. You'll end up with different ratios, but the same answers, and maybe we should look at that. So let's first look here. So in order to find z, based on angle of interest being angle 20, I'm going to have my opposite, my hypotenuse, that's sine. So sine 20 is my opposite of 6 over my hypotenuse z. My variable is in the bottom, so that means when I move it over, I'm going to have 6 divided by sine 20. I'm going to take my calculator, use my fraction button, 6 is my numerator, sine 20 is my denominator, and I have that z is approximately equal to 17.54, and we're in feet. And again, using angle of interest as 20 as my angle of interest. If I'm looking for x now, that's my adjacent. I have my opposite and my adjacent, that's going to be tan. Again, my variable's in the denominator, so when I move it over, I'm going to have 6 divided by tan 20, and x would be approximately equal to, get my calculator, 6 is my numerator, now tan 20 is my denominator, 16.48. Okay, well, if we change the angle of interest, let's say we're going to make 70 our angle of interest. Our hypotenuse stays the same, but now this becomes our opposite and this becomes our adjacent. So let's solve for z using 70 as the angle of interest. So that means I have the adjacent and I'm looking for z, which is h, so a and h. So that would be cosine 70 is my adjacent over my hypotenuse, which is z. So now, again, my variable's in the denominator, 6 divided by cosine 70, z is approximately equal to, get out your calculator, fraction button, 6 is your numerator, cosine 70 is your denominator, and you get 17.54. See how you end up with the same thing? And then again over here, if I'm going to solve now for x using my purple, which means this is my angle of interest. I'm just showing you could have chosen either one, but you label off the angle of interest you choose in this kind of situation. X is my O, and I was given my A. O and A. You're like, uh-oh, but we used tan last time. This time it's tan of 70. Remember, it's opposite, which is x, over adjacent, now which is 6. See how they are reciprocals of each other? We're going to talk about that in the next lesson. So I'm going to have 6 times tan 70 equals my x. Go to my calculator, 6 parentheses tan 70, and I end up with 16.48. Same thing, approximately equal to my x. Okay, so now we're going to set up a trig ratio, solve for the missing size, solve for the missing variables. Okay, I can use I've been given all my angles in both of these examples. I'm just going to pick one to be my angle of interest. Based on that, I'm going to label opposite, adjacent, hypotenuse. If I was only given one angle, I would use that one as my angle of interest. So I'm just going to do my setups here. So if I'm going to look for x, x is the opposite, and I was given h, O and h, that's sine. So my sine 50 equals my opposite, which is x, over my hypotenuse, which is 15. So 15 times sine 50, multiply by 15 on both sides. It will cross out divided by 15 equals x. Enter it into your calculator. 15 parentheses, sine 50. 11.49. We're in inches. Is approximately equal to my x. Now, to solve for y, y is labeled with the a, and I was given hypotenuse. Again, I'm not going to use my 11.49 I solved for x, because if I get that wrong, it's going to cause me to get this other one wrong. So I'm going to go back to my given information, which was the h. Now I've got a and h, that's cosine. So cosine of my angle of interest equals my adjacent, which is my y, over my hypotenuse, which is 15. So now 15 times cosine 50 would equal my y value. Just put it into the calculator. 15 parentheses cosine 50, 9.64 is approximately equal to your y. And we are in inches. Okay, when I come over to the other triangle over here, okay, so it looks like my recording stopped, and so I picked it back up here. This is an example where you could use both. You're looking for, use tangent and cosine. I'm using 30 as my angle of interest. So you can check your work, see how you did. Okay, this is our last one. And it says find the missing side, then find the missing angle. Find the missing side. I thought I read missing. Okay. So we're going to create a trig ratio that can be used to find the missing side. Then find the missing side. Michael is building a concrete pathway. I think it's just a repeat. So he's building a concrete pathway that's 150 feet long across a rectangular courtyard. We love to talk about courtyards. We're talking about the diagonal here. Remember, rectangular means that our angles are 90 degrees, so we can use right triangle trig here. What is the length x of the courtyard to the nearest thousandths? So this little x, I'll just draw it on a single triangle. This is our 150 feet. Here's our 34 degrees. This is our angle of interest, so I want to label off my angle of interest. Here's my hypotenuse, and this is my opposite, O and H. Sine is opposite over hypotenuse, so I'm going to have sine of 34 is my opposite, that's labeled with x. My hypotenuse is 150 feet. I'm going to multiply by 150 on both sides. It clears the divided by 150. Use my calculator. 150 parentheses sine 34. And I get 5.591. So 5.59 is approximately equal to x. What is the length of the courtyard to the nearest thousandths? We are in feet. It's approximately equal to x. Okay, kids, that ends our lesson 2 on solving for missing sides. Thank you.